Have you ever wondered why we are so attuned to symmetry or why beauty and symmetry are related? The short answer is that symmetry affects function. And here, we will talk about a method for codifying symmetry called group theory. Group theory is an area of math with an extensive history, and mathematicians haven't limited themselves to 3 dimensions. One of the groups they've discovered is simply called the monster, with 196,883 dimensions. For most applications, that number of dimensions is a bit excessive, but we can do a lot with groups that stop at 3 dimensions. This video will give us a basis that will be used to solve many different problems in chemistry, but first we need to build up a language in math around symmetry of 3-dimensional objects. Symmetry often determines function in many aspects of life. Sphere-like viruses have been found to have protein shells called capsids with icosahedral symmetry that are made of various proteins that fit together to form the shape. One example of this is the cowpea chlorotic mottle virus, or CCMV. Researchers have shown that if you take its capsid proteins in vitro, they self-assemble into this icosahedral sphere. Here you can see the 5 and 6-membered rings put together in a soccer ball-like shape. It's not just tiny things that are dependent upon symmetry for their function, of course. Cars, for example, have a plane of symmetry that runs vertically from front to back that's required for their function. If they were very different on the left and right side, say the tires were much larger on one side than the other, they would easily roll over going around a corner.